Hi guys, this is Mark. In this video, we will talk about many-to-many relations. Previously, we discussed different types of relations, one-to-one, one-to-many. Things you have learned in the previous lectures will definitely apply and be very helpful when you start practicing and using many-to-many relations. There are some considerations to keep in mind. I will try to cover as many as I can think of. And the whole area of many-to-many relations, given the possibilities of the different types of things that can be done, becomes rather wide. I have captured some of the most common use cases in this lecture, and I will be going over those examples. But at first, let's look into the actual nature of the many-to-many relations. For this, I have prepared a couple of slides, and let's take a look at those. What you see on the screen is a rather typical example that is used in a number of different tutorials and instructional materials that discuss the many-to-many relationship. We have a table called course, and there is a table called student. And a single course may have multiple students, and a single student can be enrolled in multiple courses. However, there's a number of examples of the many-to-many relationship in the real world. And for instance, in the social media, you could have a user that may publish multiple posts, and a single post could be liked by multiple users. So that's sort of a many-to-many relationship. But we will focus on the course and student table and the many-to-many relationship in this case. So here we have end-to-end. However, as you know, in Backendless, there is no built-in many-to-many relationship. And let's take a look at how this could be implemented in Backendless. So in Backendless, you could declare a one-to-many relationship. A single course can reference multiple students. And then, as you know, with the bidirectional nature of the relationship in Backendless, once we have single course referencing multiple students, by using the reverse relationship, the bidirectional side of it, for a single student, we can get all the courses that they're enrolled in. So the one-to-many relationship in Backendless ends up being a many-to-many relationship. But there are some considerations here that we will get to. But let's just stay with this, given that it is one-to-many, and take a look at how this would work for various use cases that would apply in this relationship. So now, just to solidify how this works. So for instance, in the course table, you declare a relationship column called students, and that column really becomes or is declared as one-to-many relationship that points to the student table. Likewise, with the bidirectional nature of that relationship in the student table, we get this pseudo column. It's not declared in there, it is implied, that gives us an ability to go from student back into the course or courses that refer to that student. And the way that pseudo column is declared, it's the name of the parent table, and then the name of the relationship column in the parent table in the square bracket. So this is rather critical to know and to keep in mind how we can refer to the parent table from a child table in the one-to-many relationship. So now with this in place, let's take a look at some of the examples of how this would work. Now, I have prepared a sample database that contains data, both courses and students. It's very, very trivial and simplistic, again, just to keep things simple. And you would need to import that data into Backendless so you can play along and see how the queries that I will be going over would work. So switching to Backendless now, let me show you what that schema and the database looks like. So in here, you will find that there is a table called course, and it contains 4 different courses. And as far as the actual data, there is a course ID, there is a course name, and there is a relationship to the student table. And the student table is right here. It contains 5 students. And then as you can see in the course, I have relationship to the students. So and then there is the actual correlation is different, where some courses, for instance, history, has 4 students. As you can see, there are 4 objects assigned to the table. And then this one, which is philosophy, has 3. This one has 2, and this one has none. And you will see why I'm doing this. By the way, you see that there is a link in the description for this video where you can download a zip file to import into Backendless, so you have exactly the same data. If you're not familiar with how that import works, what you will need to do is go to the Manage section, select Import, and then click this Browse button. So once you click this Browse button, select this Courses and Students.zip. The link is in the description, and then click Import. Backendless imports this data very quickly, like within, I'd say, maybe 5 seconds, you will have exactly the same data. So this is the data that we have, and the relationship is one-to-many from course to students. So now with this in place, let's take a look at various scenarios that I came up with, so you can see exactly how it would work going from courses and working with related students, and how to work with students and using the related course information. So the first example is going to be getting all students for a course. So given a course, we want to get all the students. This is something that we already covered in this video course, where we were getting all the related objects. So this is something that you should already be familiar with. And then in this case, so we have this course, and then these are the students that we want to load. Let me demonstrate how this works, just to refresh your memory. So in Backendless console, if we select course and go to REST console, one thing that you can do is in the relations, you can specify students, and then just click get. So what this does is it loads all the courses with the students that are already included with every single course. Okay, so this is the one-step retrieval, where we get courses and students are right there. However, this approach, I do not recommend this approach, because I believe that in most of the UIs, you would be basically getting a list of the primary objects and then, or entities, and then as user navigates in, then for a specific course, you'll get a list of all the students in that course. So making it UI driven would be important. So the actual mechanism that I recommend would look like this. So if we need to retrieve students for a specific course. Since we are retrieving students, we go to the student table, and in the where clause, we need to identify what course we will need to get the students for. And to do this, now we're using that bi-directional reference, basically that pseudo column that identifies the course that points to the students. So this goes like this: course, and then the square brackets, students, and then we can say name equals history. And then this where clause identifies the course that relates to the students. So any student that has the reference from that history course pointing to it will be returned by this query. Click get, and as you can see, we have 4 students that were returned, and all of these students are enrolled in the course that is history. So that is basically how you retrieve it for child objects for a given parent. That doesn't have to be named here. If you know object ID of that course, you could just say object ID and specify that object ID right here. And that will work just fine. So as long as you can identify specific parent, then for that parent being the course, you can get all the child objects that relate to that specific parent. And back in the slides, to summarize what I just described in the codeless format, it would look like this. All right, so we are going to be retrieving all the objects from student for that specific where clause. Course, square brackets, student.name equals history. If you are programming with code using one of our SDKs, once again, the where clause stays the same regardless of the actual programming language that you're using. So it becomes really a universal way to structure that query. So that's getting all students for a course. Next one is getting all the courses for a student. So basically getting a list of all the courses that reference a specific student. How would this work in Backendless? Let's take a look. So in here, since we are getting courses for a student, it means that we need to go into the course table. And then in the course table, we want to get all the courses for a specific student. So we have a student with name David. And in order to identify that we're interested in all the courses where David is enrolled, what we do is we say students, which is the relationship column, dot name equals David. Click get. My bad, it is students. So now here we have, David is enrolled only in history. Let's confirm if this is indeed the case. So we go to students, and here's David. And then from here, for David, we can navigate to the pseudo column and click this link. And that's going to be the course where David is enrolled. So now we know that David is enrolled only in history. So that's how you go from referencing a child to get all the parent objects that the child is associated with. For instance, if we take a look and just find a student that is enrolled in more than one course. So in here, like for instance, this student, Becky is enrolled in 3 different courses. So we click the link, and then these are the courses, okay? So for instance, if we do the same thing with where clause, in here we say students dot name equals Becky. Click get, and now we got 3 objects. So that's how you go to identify all the parent objects for a specific child objects, or getting all the courses that a specific student is enrolled in. In this case, for the codeless version of it, that's going to look like this. So students.name equals, and then specific name, or if you want to use specific object ID, now you know how to do that. So this is kind of the most common use cases of getting children for a specific parent or getting a collection of parents for a specific child. Let's move on and see what other examples that I have here. All right, so here we want to get all courses sorted by student enrollment, meaning that we want to get the actual courses ordered by however many students they have. And in this case, we see that, for instance, this one would be number 1 because it has the most number of references coming into it. This would be 2. It has 2 students. This would be number 3. It has only 1 student, and this is number 4. So the more students they have, the higher in the list it needs to be in order to get the result that we want. So that we want to find out, perhaps, in other words, get all the courses sorted by popularity. The most popular and then the courses with the highest enrollment should show up first. Let's see how that would work in Backendless. So in Backendless, in order to get this done, I will have to use a feature that I haven't discussed yet. It is actually will show up later in the course, and I generally dislike providing information in my courses where I describe something that actually, or use something that is described later in the course. But relationships in Backendless is such a thing that is so intertwined with many other features. Therefore, I kind of was forced to demonstrate how this feature works without providing a formal introduction to that feature. And but it's quite powerful, and it will be cool and interesting to see how it works without even getting a formal introduction. So we want to get the courses by popularity. Okay, so since we are getting courses, that means that the course table needs to be selected. I'm going to get rid of this where clause that we used previously and clear this response. And in order to sort courses by the number of students enrolled in it, we need to get the number of students for each course. How do we get the number of students? Well, for this, there is a wonderful function that is called count. And the function, the count function, can be applied to relationships. And for this, what we will need to do is open up this column and properties. So we will be requesting a specific property, and that property is going to be dynamic, okay, which uses a function. By the way, we talked about database functions. I did not mention count in there because it's a separate type of function that is called aggregating function, but nevertheless. So first of all, we need to get the number of students enrolled in every single course. And for this, what we're going to do is we're going to say count, and then relationship column, students, and then we put object ID. So we want to count all the students that every single course has, okay? And we can say as student count, okay? So this will get the number of students in every single course. Since we are identifying a property, if I leave it as this, I will just get just that property, but I want to get all of them. So I will also add star, okay? Now, another thing that would be important whenever you use count is to say that we want to get the data broken down for each individual course. And in order to do this, we need to group the data. And I know that may start sounding complex, but just take it for what it's worth. We need to group the data by individual courses. And for this, we need to group by object ID. Okay, I will demonstrate what's going to happen if we don't group it by object ID. But let me run it first, okay, and see what we got back. So what we got back is a list of all the courses that every single course has a property called student count that includes a number. So this course, biology, has 2 students. Philosophy has 3 students. Nobody is enrolled in art. And history has 4 students, okay? So this is what we get back. By the way, if I don't group it by object ID, I'm going to remove it now just to demonstrate. What we're going to get is an aggregation across the entire course table. So it basically will calculate that the count is 9. For all courses combined, it is going to be 9. And then this the remaining set of the properties, just how a database works, it just picks one and put it in there. But it's really relevant because when we aggregate across all of them, the only true value is going to be this one, 9 across all courses, which is not what we want. We want to differentiate it on the per course basis. And in order to do this, we have to group by object ID, basically grouping by whatever makes every course unique. An object ID clearly will make it unique. We can group it also, or we can group it by name, and it will be the same thing because name of the courses are unique. So if you run it this way, you will see that it's going to be the same thing. But grouping by object ID is the guarantee that the aggregated data of how many students each course has is the sure way to do this. So now that we have all of this data, how do we determine which one is the most popular? Well, that is the sorting function. And the cool thing about the setup that we have right now, since we assigned an alias, which is student count, which became sort of its own property name, okay, what we can do is we can actually sort by that alias, okay? So if we turn on sorting, in here in the sorting dropdown, you will see that student count is already there. So if we select student count and then rerun this query, now all the data is sorted by student count, which is a dynamic property. So this is becoming advanced, but this is the true power of Backendless, and it goes way beyond that, as you will learn further in this course. But we're already doing something that is really, really powerful because we're basically aggregating data on the related table and we're bringing it back and we're sorting the primary objects, the parent objects, and this is what you get. And then we can just put it in the grid, and as you can see, it is sorted by student count. So history is the most popular course. I think it is pretty cool. So let's go back to the slide and summarize everything that we have put in here in the form of a codeless block. So, and here, getting courses sorted by student enrollment in the form of codeless would look like this, which is exactly the same information that I have in REST console, but now kind of formatted according to the arguments that we have in the codeless block. First of all, in the properties, we counted students. A student count, by the way, in the REST console, when I was playing with it, I said students.objectID. You can actually just reference the relationship column and it will be the same. Then star to get all other properties from the course table. And then sorting, we sorted by student count, because student count is the alias assigned to this function. And we're grouping by object ID. And that will produce the same result that we saw in Backendless console. I think it is pretty cool. For those who write code, it is going to be exactly the same thing, because whenever you retrieve data from Backendless with a find function, the arguments are going to be exactly the same. I think that there's going to be an object that is called data query builder. So data query builder will have all the same properties that are described here. Let's move on. And now in this example, I review the use case of getting the students sorted by how many courses they are enrolled in. In other words, we want to get a list of students ordered by the students who are the busiest, by judging by how many courses they take, to the ones that are least busy, or if you want to call them lazy, doesn't matter. Everyone has their own circumstances. But anyway, so we will be getting a list of students ordered by how many courses they are enrolled in. Let's take a look and see how that use case would work in Backendless. By the way, this visualization here says, well, this student is enrolled in 3 courses. There are 3 lines coming in. This one 2, this one has 1, and this one has only 1. As a result, this is going to be the ordering at which we expect to get it. In Backendless console, let's switch to the student table, because if we are getting students and we want to order them by how many courses they're enrolled in, we will be retrieving data from the students table. Therefore, student is going to be the table that we send this query to. The approach here is going to be identical to the one that we just described, where we're getting courses by ordered by how many students enrolled in here. And in this case, we are getting students, so we need to know how many courses they are enrolled in. To know how many courses they are enrolled in, again, we're using the count function, and we are declaring a custom property. So it's going to be count, and then guess what we put into the count as the argument? Well, if you answered if your answer was pseudo column, you're absolutely correct. So here we will say course, and then in the square brackets, students, and then we assign an alias, and we say as course count. Something that I don't remember whether I need to put object ID here or not. Let's give it a try first as is, and then we also will add star and C. And by the way, we need to group again by object ID. Let's click get, and this one is invalid. So let's see if I need to put object ID in here. Perhaps it will cure that error. Click get, yes. So in here, we need to specify object ID. So what we have is we calculate how many parent objects reference each and every student. And that number is going to be provided back to us by the system as a property that is called course count. Indeed, when we got it back, there's Becky has 3 courses, George has 0, David has 1, and so on. So now, since we have this property, we group the data by object ID, so we get each and every object with that property. Without object ID, we will be getting just one that basically references all the combinations across all the students. So we need to differentiate it by object ID. Okay. Now, since we have this data, all that is left is to sort these students by the course count number. And for this, if we turn on sorting, select course count, rerun this query, and now they're sorted by the number of courses that each student is enrolled in. And then as we can see, Becky is the one with the highest number of courses, actually both Anna and Becky. And then we have other students in the list. In the grid view, this is what we got back. And that's exactly what we were looking for. Let's take a look at what this would look like with codeless. And with codeless, this is what we get. Again, structurally, it is going to be identical to the previous example where we're getting courses sorted by the number of enrolled students. And again, this is a count function that references a property of the parent object that makes that parent object unique. And that's the object ID. And then the reference to the parent object is course, and then students in the square brackets. All right. And then we sorted by this course count and grouped by object ID. That is very, to me, it is very straightforward, but I recommend that you play with this just to see how that would work for you. By the way, I see a typo here. It needs to be students, plural. Okay. So if you are going to be replicating this example by looking at this screen, make sure that you type in students, because the relationship column name is students, plural. Let's move on. Okay, so this is a fairly common scenario where you want to get parent object that has no child objects. And in this case, it is going to be get the courses without any student enrollment. In order to get this working in Backendless, let's switch to Backendless console. Since we are getting courses without enrolled students, course table is the one that we send the request to. And in here, I'm going to close all these boxes because we don't need them. And this can be solved just with the where clause. And to get it working, you type in the relationship column name, students, and then you say object ID is null. So in other words, we're getting the courses that have no students referenced in that relationship column. Click get, and as you can see, art is the course that has no students enrolled in it. Let's verify this. Go to data browser. Art, as you can see, has no students. So that's a query that will make it possible to get parent that has no children. And the codeless version of this would look like this. Again, just the where clause to make that query. And finally, the example, which is the reverse of the previous, get students not enrolled in any courses. So we want to get all the children objects that have no reference from the parent. Let's see what that would look like in Backendless console. And since we are getting students, the request is going to go into the student table. So let's select this. And in here, it's going to be very similar to what we did in the previous example, where we say course, students, object ID is null. Click get, and we got one student that is not enrolled in any courses, and that is George. Let's verify this. In here, if we go, and this is the line for row for George, and as you can see, it has no courses referencing that student. And then this is the where clause that makes this happen. Back to my slides, and this will be the codeless version. Again, this query is driven entirely by the where clause. This has gotten to be a pretty long lecture, but I think it needed to be because there are a lot of different possibilities that relate to many-to-many. And something that I want to mention is a caveat or an important constraint that we will look into further in the next video. And this constraint goes like this. So here we have relationship between courses and students. And then this relationship that works with this schema that we have, course and student tables, provides a way where we can just establish the linkage between these two entities, courses and students. However, a general design problem with this approach is that if there is a property that is associated with the relationship itself, such as student enrolled in the course, the properties of that relationship could be date of enrollment, how much they paid for that course, grades, like what grade that student has for that specific course. With this schema, there is no room for that data. Because if we were started putting it in the student, then it's not clear for which course that grade is going to be in. So there we will have to start doing something to capture that information. And that is a very important caveat to keep in mind. If you don't have actual properties of a relationship, then the schema shown here will work just fine. However, if the actual relationship has additional properties, then there's going to be a somewhat different design. And we will look into that in the next lecture. Thank you for watching this video, guys. I do hope you find it useful. If you have any questions, please leave them as comments, and we'll be happy to provide additional information. Again, many-to-many is not a simple task. It's something that can be quite challenging, and I hope that I gave you an idea of how that would work in Backendless. Thank you for watching, and as always, happy coding.